All right, since we're going to be e-learning on Thursday and Friday, I decided to make this video for everybody, just in case you are not able to Zoom. So on a previous worksheet from this week, we learned that an alpha decay or an alpha particle is just a helium atom. It has a mass of 4 and an atomic number of 2, right, which is helium on our periodic table. And that a beta particle is essentially an electron. It has no mass and a charge of -1. I'm going to do a few of these examples with you. You do need your periodic table to do this when we do the last section. So we're going from uranium-234. So uranium-234 is our mass, uranium, and we are going to go to thorium and 230. So these are the masses. We need to check the periodic table to tell us what the atomic number is. So uranium is down here. Uranium is 92. So we got an atomic number of 92, and then thorium has an atomic number of 90. So we want, when we do our equations, we want to balance each side. We want our masses to be balanced, and we want our atomic numbers to be balanced. So what is going to be, is it going to be an alpha particle or a beta particle? Right, for this one, it's going to be an alpha particle. So 2 plus 90 gives me 92. And then 4 plus 230 gives me 234. This is how I know that it's balanced. All right, so this is going to be alpha. And I'll do 2 more, and then I'll have you guys do the rest. So thorium, which we just checked our periodic table, is to a mass of 230. And an atomic number of 90, and it's going to go to radium. So this particular atom of radium has a mass of 226, and let's find it on the periodic table. Let's see, radium. Here it is. Okay, so it's got an atomic number of 88. So I'm going to put 88 here. And my symbol is going to be Ra. And I need to figure out what, is it an alpha particle or a beta particle, will give me a balanced equation. So 2 plus 88 will give me 90. And then 4 plus 226 will give me 230. This is going to be another alpha particle. Let's see. Let me find one that's going to be beta. Here we go. We'll do number 6. So lead, 214. Lead is Pb on your periodic table right here, Pb. And it has an atomic number of 82. 82, lead is Pb. And it goes to bismuth. I'm not sure how to pronounce that. Here we go. It's got an atomic number of 83. And this particular one has a mass of 214. And what is the symbol? Bi. All right, then we need to decide if alpha particle or beta particle is going to have this balanced. I know that 2 plus 83 does not give me 82, so I'm going to try my beta. So -1 and a mass of 0 is my beta particle. So -1 plus 83 gives me 82, and then I don't have a change in my mass, so my mass stays the same. This might be an easier way for you to decide if it is an alpha particle or beta particle, because if your mass doesn't change, you have a beta decay. So looking through these, right, my mass changes here, my mass changes here, my mass changes here, my mass does not change here. My mass does not change here. My mass does change, it doesn't change, it doesn't change, it does change. So this is like a quick way to get your types of decay without doing all of this first. So that's this section. Let's do one of these or two of these. Plutonium 218, we want to have it undergo alpha decay. So we got our plutonium, which is, let's see, or excuse me, polonium. Let's find it here. Here it is. It's got an atomic number of 84. And what did we say? PO. And we know it undergoes alpha decay. These are all going to have a helium, my alpha decay. So 82 plus 2 gives me 84. And then 214 plus 4 gives me 218. So what is this? What is this element? We need to find out what element has 82 protons, which is lead. Right. We are not so much going to check out our mass because our mass just tells us what our isotope is, but we want to know what, there's only one element that has an atomic number of 82, and this is the number we want to check when we're deciding what element it is breaking down to. So let's do one more, and then I'll do one on the back. So polonium, this one has a mass of 214, right? But it's still polonium, so it's going to have an atomic number of 84. It's undergoing alpha decay. So let's see. It's going to give us, it's still 82. And this will be 210. Right, it's still 82, so that is still lead. So it just has a different mass because it has a different number of neutrons. All right, so this is alpha decay. And then let's try beta decay. So we want lead. Lead we just did is Pb. And it has a mass, this particular one has a mass of 210 and an atomic number of 82. And we're undergoing beta decay. So what minus 1 gives me 82? It's going to be 83. And then I have no change in mass, so my mass will be like this. So now I have to figure out what element has 83 protons. 83 protons gives me Bi. Okay. I'll do one more. We'll do this one. This is the element. So 210 Bi from my periodic table. It has an atomic number of 83. It undergoes beta decay, so I know it's 84 minus 1 gives me 83, and then my mass doesn't change, so 210. So what element has 84 protons? It is going to be PO. All right, that's how you do it. So try the rest of these. If you don't have a printer, you can just write out the equations on a separate sheet of paper and make sure you're uploading it to Canvas.